interpreting a graph of position versus time for vertical projectile motion. Let us interpret the graph of position versus time for a vertical projectile and determine the equations of motion. We shall also find the initial velocity, maximum height, etc. The graph shows the motion of a ball that was thrown vertically upwards by Vernon from his balcony some distance from the ground. The ball takes 0.5 seconds to reach the highest point before hitting the ground. Calculate the following quantities: the height of the balcony above the ground, initial velocity of the ball, the maximum height that the ball reaches from the ground, the final velocity of the ball when it reaches the ground, total time of flight of the ball. Solution: we first observe the graph and deduce that the upward direction has been taken as positive. From the graph, we can see that the initial position of the ball, that is, at 0 seconds, is plus 6 meters. This is when the ball was released from the balcony. So, the height of the balcony from the ground is 6 meters. From the graph, we can see that after a time interval of 0.5 seconds, the ball reaches the maximum height. We also know that the ball has 0 velocity at this position. We shall use this information to calculate the initial velocity of the ball. Consider the initial position to be the position when the boy throws the ball. We consider the final position to be when the ball has reached its maximum height above the ground. The acceleration, due to gravity, will be in the downward direction, hence negative. From the equation of motion relating to velocity, Vf equals Vi plus g delta t, substituting the values, Vi equals 4.9 meters per second. This is also the initial velocity for the entire flight of the ball. Continuing with the same initial and final positions, we can find the maximum height of the ball. The displacement of the ball can be found in this time interval. Delta y equals Vi delta t plus half g times delta t the whole square. Delta y equals 1.23 meter. The position of the ball, with reference to the ground, can be found knowing the initial position. Y equals y0 plus delta y. Here, y0 is the initial position of the ball, and it is positive 6 meter. Y equals 6 plus 1.23 equals 7.23 meter. We now consider the initial position to be when the ball has reached its maximum height above the ground, and the final position to be when the ball hits the ground. The initial velocity is 0. The final velocity is unknown. The displacement is in the downward direction. It is simply the difference between the final position of the ball on the ground and the initial position of the ball for the motion that we are considering, that is, from the highest point to the lowest point. Delta y equals yf minus yi equals 0 minus 7.23 equals negative 7.23 meters. The final velocity of the ball when it reaches the ground can be found using the equation of motion. Vf square equals Vi square plus 2g delta y. Substituting the values, Vf equals plus or minus square root of 141.71 equals plus or minus 11.9 meters per second. Mathematics gives us two values of velocity. However, we reject the one that does not fit our example. Here, the final velocity when the ball hits the ground will be in the downward direction, and the upward direction is the positive direction. Hence the final velocity cannot be positive. It is negative. Vf equals negative 11.9 meter per second. The final velocity of the ball when it reaches the ground is 11.9 meters per second in the downward direction. To calculate the total time of flight of the ball, we consider the initial position to be when the ball is thrown up, and the final position to be when the ball hits the ground. The initial velocity is known. The final velocity is also known. The total time of flight of the ball can be found using the equation of motion. Vf equals Vi plus g delta t. Negative 11.9 equals 4.9 plus negative 9.8 times delta t. Delta t equals 1.71 second. This is the total time of flight of the ball.
Starting to feel it? Now go master it with Askmaski.